Guys, AlphaKoala here. A couple of people have been coming up to me saying that they've got a project due for statics and materials, and they kind of don't really know where to start with it. So I thought I'd kind of go over some basics to kind of give everyone a feel for what they should do in a statics materials sort of project. Now, generally you'll be building something, normally like a bridge or a truss or something along those lines, and you got to try and choose, the correct design, the correct materials, and that's kind of what they're looking for. So the first thing you should really do is try and understand your project outline. So we'll call that the client brief, right? Because that's basically what it is. They're kind of telling you what they want you to do, and you gotta kind of figure out a really good way to do it and get within all the constraints, which is another important thing. You must understand all the constraints. This is length, weight, stuff like that, how you're gonna be graded. Alright, so that's pretty basic. For this, we're gonna use the example of a truss, just because, it kind of gives us somewhere to go. The first thing you're gonna want to do if you're doing a truss is select your truss type. So we'll put that there, truss type. Now, the three major ones are the Howe, the Pratt, the Warren, and I suppose maybe the cage truss. Maybe, but you're getting pretty lenient with the cage truss. Now, the Howe and Pratt are basically the same sort of design. One's just kind of flipped upside down, so the compression and tension is going to be opposite. Once you've kind of identified, some information on the truss types, you got to try and figure out how your truss will be loaded. Will it be loaded from, the center of the truss? So, is it going to be straight down, or is it going to be, spread across the truss? Or are you going to have, some kind of, like a cantilever truss, where it's put in over there and, kind of attached to, something here. So that's called a cantilever bridge. So if you're going to make a truss like a cantilever bridge or something like that, you're going to really want to kind of look into how the force is spread for that. Okay, so now that you've got the concept of your design down, that's going to be your truss type, sort of a basic understanding of how it's going to interact with the project, you're going to want to be looking into some real-world examples. Now, most projects require you to report at least one real-world example, because real-world examples kind of make that connection between theory and practical. So, ideally you want to choose a famous example. So for a truss type, you might choose the Sydney Harbour Bridge or something like that. Something famous and easily identifiable, because that's really that's the kind of stuff they're really looking for, is famous bridges. They've got a lot of information on them, stuff like that. Your next step will be materials selection. Now, there are thousands of different engineering materials to choose from, and it's not really that feasible to go through each individual material and kind of look at them individually. So the first thing you got to do is kind of rule out the materials that will not be used. So if we go back to our example of a truss, and you look at maybe metals. Now, there's a lot of advantages to metals. They're strong, their weight to strength ratio is pretty good. Some things to consider is, if no one has any metalworking experience or any metalworking gear, it might be difficult to construct a model out of metal. If you have to construct a model, you got to kind of look at the weight, stuff like that. It might not be that optimal to use metal, especially if you've got a project that kind of demands where your object will fail. Because if your bridge is supposed to kind of fail at a set number, and you've got metal being ductile and kind of changing shape, if you got to change the shape of the bridge or truss, which will kind of change the way the forces are exerted on it, and you might end up going over your limit or, going under a lot faster because your bridge has changed shape. So, they're kind of interesting to look into. So, it's probably worth considering just cutting metals out. Of course, that's kind of a possible viable option, but for this video, we're going to assume that we can cut metals out. The next one will be polymers. Now, most people can kind of intuitively think about a bridge made of rubber and go, that's really not going to work. I mean, it's going to flex, it's going to bend, it's going to be wobbly. It's not really going to be a stable structure. Polymers are actually very vulnerable to temperature as well, because they break the van der Waals forces between them. So if you're going to make something that's going to be out in the sun, polymers aren't really that great of a choice. So we'll take polymers out. So that leaves us with ceramics. And ceramics are great. They're strong. They don't stretch very easily, which, can be a good thing or a bad thing depending on the situation once again. They're very hard to work with, pretty costly. They're also got a very unstable microstructure. And I say that very loosely because they've kind of got these little elliptic, I can't actually pronounce it. They got very small cracks at a micro level, which can make them vulnerable. One piece could be more vulnerable than another piece. Not a very consistent material when it comes to wide load. So, in terms of making a giant bridge out of porcelain, it's probably not going to work. So, it might be worth just, scrapping ceramics. And, we've gotten rid of metals, polymers, ceramics, so what's left? Well, we've got rid of them, but we've got composites left. Now, composite kind of takes an aspect from two materials and kind of merges them and makes them better. So composites are really what you want to look at. Now, there's a lot of different composites. You can have like your nanotubes, and nanotubes are wonderful. They're light over air, they're really strong, they're absolutely fantastic. If you can make your model out of nanotubes, and the idea is to like maximize strength, that's going to be great. It might cost you, $200,000 to make your model bridge, but you're going to have a great model bridge. But for the average person, that's probably going to be ruled out. So you kind of want a composite that's really feasible. It's got to be cheap. It's got to be reasonably easily accessible. Probably if it's ever going to need to be repaired, you want it to be easy to, replace, easy to work with, stuff like that. And the best composite for this is actually an organic composite called wood. So we'll underline that, because that's one of the really big composites that's really popular. So basically, there's lots of different types of wood, all of the different compressions and tensions and all the different variables about them and densities and stuff like that. So you really got to kind of look into that. A great way to find information on materials is actually just to use a standard search engine and look up something along the lines of material property data. And that will turn up some generally good results, normally at the top of the list, maybe 2 or 3 down. Just poke through them all and you should be able to find something that will turn up some, good information that you can hopefully use. Another important thing with statics and materials is, and that, as with any assignment, is to make sure you kind of understand the topic before you kind of just jump right in. Because you can go through all this, you can be looking at your materials and not really know what any of the numbers mean. So it's great to get kind of a feel for, sorry about this, just cleaning my board. It's kind of good to get a feel for some key terms. Just highlight that, that's quotations, that's a pretty good phrase. I wouldn't really go changing that, I'd put it straight in like that. Anyway, some key terms. You want to be looking for things like what the word ductility means, the word strength when they refer to materials, maybe compression yield point. That's a good one. Yield. Maybe the, ultimate tensile strength, UTS. There's some big ones, and you should really have a decent understanding of them. Otherwise, you're going to get data and not actually know what it means. And if you don't know what the data means, you're not going to make a very good decision. So that's kind of like a starting point. Now, you're probably going to find multiple suitable materials. And there's not always a best material. You might even consider using 2 materials, or you might kind of narrow it down to like 5 suitable materials and then decide, you look more into your design and requirements and then maybe choose a suitable material later. And that's fine. It's just something different groups go through different processes, or different people go through different processes in selection. And that's absolutely fine. Now, a lot of courses, especially at university or college level, are going to ask for you to do some of your own testing. So you're going to want to do some testing procedures. And if anyone hasn't done a prac in a long time, you're not the only one. But you generally want to do like a prac write-up or something like that and kind of outlay kind of a bit of science behind your procedures and why you think they're good. Some things you might want to be testing on if you're choosing wood, glue, or joint testing can be a very good option, because then you've kind of got extra information on how your materials are going to work together, and it gives you kind of an insight to how your bridge will function at the joints and where it will break and how much glue you should use and stuff like that. So it's actually useful and probably should be included into your assignment. Just because you're doing testing doesn't mean you should rule out research. A lot of people have done testing on a lot of glues in a lot of situations, so you'd probably want to do some research, and you can probably make a decision based on just the research, but it's great to include some actual testing, because that's generally what they're kind of looking for. Some other testing you might want to do is like, I don't know, maybe if you're really game, you might want to do some material testing, like maybe the information you found online is a lie. Or, I know particularly with woods, you have to be careful, because some strengths are measured when, the tree's still kind of alive and it's still filled with water and stuff like that, and other sites will kind of measure the wood when it's bone dry, and some people have like 12% water in it. So it's kind of something you gotta look out for, is the water density of the material. So you can kind of get your material and see that at the density that you've got it, the water density you've got it, it still functions as you would predict it to. So that's kind of like a good test to do. After this, you're probably gonna be looking at like more back to your design of your truss, and you're gonna be wanting to like optimize your ratios or choose appropriate ratios. Because there's no point having a bridge going, this far across, or a truss going this far across and being this high. Because that's kind of like a big waste of material, especially if it's like 2 centimeters. Because that's kind of like a lot of waste. You could probably clear that with a paddle pop stick. So it's not really that practical. You gotta kind of choose ratios and maybe choose the correct angles between joints. Like, a truss might look like that, and that might all be 60-degree angles. And that's gonna be like a Warren truss. Then again, you might want to try and make your bridge like, 85, 50, probably 5-degree angles in there. And that's going to be a lot less practical. So you kind of want to choose an optimal angle depending on your bridge. Obviously, if you're doing the Warren truss, you're already going to have your angle chose for you. But you still got to choose like your material heights and widths between joints, stuff like that. You can do a lot of calculations by hand. You can kind of calculate how much tension will be on each member, how much compressive force will be in each member, so our tension's actually pulling. And from that you can kind of maybe go back to your materials and say, well, this material actually isn't appropriate, or this material is appropriate. So, you know, you might even decide to use multiple materials. It really depends on how much each member is supposed to be handling. Once you've done all that, you probably want to run a simulation. Now, there's a lot of bridge simulators, or truss simulators, general project simulators. Generally, you'll be provided one which they want you to use, if it's a course, especially college, university level. And if you're kind of doing this at a high school level, you might have to find your own. But, you know, they're basically all pretty much the same, just, you know, all vary a little bit depending on niceties. The next thing you're probably going to have to do is actually build your project. So you'll think might look great on paper, but if you can't build it, it's not really that practical. So I suggest, if you're doing trusses or something, you might want to plug something into your search engine, like making model bridges 5 steps. And I kind of leave it at that. I probably wouldn't edit that phrase too much, because that's a pretty good phrase to kind of put directly into your search engine and actually turn up some good results. You know, once again, if it's not a good result at the top, just kind of scroll through and you'll probably find something good.